Now, once you understood this locking mechanism, then you would understand that, if we are actually working in a particular shared resource, let's say count, we have used a particular lock. Let's say, for example, we had another shared resource, and let's say I would call it balance over here, and that is also 0 for now. And I actually want to work on balance, once let's say my entire for loop completes, I want to say balance equal to balance plus count. This is just a random thing which I'm doing. There's no logic behind this, but this is the thing, which I actually want to complete, doing once I complete with my for loop. So now if I want to actually work on balance, probably I might think that, I can have a new lock, let's say lock 2. And what I want to do is basically acquire my lock 2. So I would do lock2.lock. And then, once this entire balance is updated, I would say lock2.unlock. This is something, which I would want to do in the other threads as well. So I'll put the lock over here, and then I would unlock it over here. And I can actually, unlock it with the finally, block of try as well. So what I'll do is probably in this, I could add the lock2.unlock so that I'm sure that, anything happens within this, I do have this unlock happening over here. So this is fine. And if I try to actually now run this and, check what is the balance, I would actually, want to print this over here. So now when I actually run this, we do have, count is 20 and balance is 30. And then when I actually run this again, we have again, same thing, count is 20 and balance is 30. So this works fine. But when you're actually working with multiple locks, you have, multiple shared resource, then it may happen that you are locking and unlocking every time in your code. And at some point of time, it may happen that there are multiple threads in your program. One thread has a particular lock. Another thread also has a particular lock on a particular, resource, in fact. And one thread is waiting for a resource to get free, and another thread is actually waiting for another resource to get free, and both of them are stuck in a deadlock. So for example, this thread 1 over here has locked using the first lock and is actually working on the count. And then finally, that thread 1 is actually waiting for a lock 2 to work on the common thing balance. In thread 2, I'm actually wanting to work with lock 2 first. This is something which I'm doing right now, just to simulate a particular situation and show it to you that I actually have lock 2 first. I am working on balance, and now I'm waiting for lock to work on this particular count over here. So now what's happening is that if my thread 1 starts executing first, then it would acquire the lock, work on count, wait for lock 2 to get acquired to work on balance. At the same time, my thread 2 begins, it acquires the lock 2, works on balance, and now it's waiting for lock to work on count. But now lock is already acquired by the thread 1, and thread 1 is actually waiting for lock 2, but lock 2 is acquired by thread 2 and it is waiting for lock. And here we will never achieve a situation in which the thread 1 is actually getting a lock 2 just because, lock 2 is already locked by the thread 2, and thread 2 is actually getting the lock just because, lock is already locked by thread 1. Both of them will never reach the finally block to actually unlock both the locks, and this is where we would have a deadlock. So now let's go ahead and try to run this now. So now, as you can see, we somehow did not actually land in a situation in which we actually had, a deadlock. And as you can see over here that, balance is 1, and this is some sort of an inconsistency which has happened over here. Now, another way in which I could try to simulate a deadlock is by actually using locks within the synchronized blocks. So instead of, reentrant locks over here, I would just comment this out and actually create a string lock1, and I would just call it lock1. So we have lock1 and we have lock2 over here. And now in the run method of my first thread, I actually want to synchronize this whole part using my lock1. So instead of actually locking it like this, what I would do is I would actually create a synchronized block over here on the lock 1, and this part is going to be in the lock 1, and then this part, I would not have my lock 2, but within my lock 1 I am actually wanting to wait for lock 2. So this is going to be synchronized part of lock 2. So now within this particular block I'm actually trying to work on this balance. So let me format it a bit. Okay. And we have to change these two to static, which is fine. And in the finally, we don't need to do anything because these are not re-entrant locks. We are just wanting to create synchronized blocks for lock 1 and lock 2 over here. Let me just terminate this program and clear the console over here. Now we do have, lock 1 and lock 2 over here. I would do the same exact thing in the second thread. Instead of, locking it like this, what I would do is I would have a synchronized block for lock 1, and within my finally I would not have anything. And within my synchronized block of lock 1, I'm actually wanting to work on, the balance part. So I would just, cut things from there, and I actually want to gain, the synchronized lock for lock 2 as well. So now let's put this finally just where we had our try, so that we do not have any parentheses error. And I'm trying to, begin with the thread start, everything. Now let's try to actually run this. Now we do have, our program terminating properly. Now the reason is because, we have this lock 1, lock 2 in the same order in which we have actually acquired it. Now when I actually try to do it in a reverse order, I first have my lock 2 and then I actually have my lock 1 in this particular order. And now when I actually try to run this, and this does work properly, and the reason for that would be because we can release this particular lock 1 for another thread to use it, just because we do not know exact times when we actually are working with lock 1s and lock 2. So let me simplify this code a little bit so that I'm able to work and create a proper scenario of deadlock for you. So I'm creating a whole new file, and I would call it deadlock. And in this, I'm actually going to create my main method and simply going to create lock 1 again. So this is string and this is lock 2. Now in main, I'm going to create a thread 1. This is going to be new thread, and within this new thread, we have new runnable. And in this, as usual, we would override the run method. And in this, basically, I'm going to create a simple synchronized block with the lock 1. Now within this block, I'm first, telling that we are inside thread 1 on lock 1. Okay, and now I'm actually wanting to work on, let's say, another resource, and I would create a new synchronized block with lock 2 now. And now within this block, I would, just do a simple sysout again. I would write inside thread 1 on lock 2. Now I really want to work exact same way with my thread 2 as well, except that now I'm actually going to reverse the orders of these two locks just to make sure that when my lock 1 is acquired by the first thread, my lock 2 is acquired by the thread 2, and then at the same time thread 1 is waiting for lock 2 and thread 2 is waiting for lock 1, and we might get into a deadlock situation over here. Now let's try to actually run these both threads. So we would do thread 1.start, and thread 2.start, and let's see if this thing does land into a deadlock situation or not. So let's try to now run this. We are inside thread 1 on lock 1, and then we are so let's actually terminate this particular program. We are in thread 1 on, so we are in thread 2 over here on lock 1, and then we are on thread 2 on lock 2. So yeah, now here I'm trying to run this. We are inside thread 1 on lock 1, okay, and then we are inside thread 2 on lock 1, fine, and now we are not able to go ahead because thread 1 is actually waiting for lock 2 and thread 2 is actually waiting for lock 1, and we are in a deadlock situation successfully. And this is exactly what you have to avoid. This is exactly what might happen within a number of threads if you're running and you do not know what is happening when, and then at a particular point of time you might land into a situation that it is possible for your program to actually run successfully, just the way we actually worked on a complex program earlier. It may be that your program actually runs successfully even though you have different locks for different things, and then you're actually locking some things and then not locking other things within them. But then it may be that you are in a particular situation in which you do land into a deadlock situation, and that is a very bad situation to be in. You have to actually make sure that your program never enters a deadlock situation, or you at least prevent your program to enter into a deadlock situation. One way to actually avoid this whole deadlock situation is to use these reentrant locks. Whenever you are using these reentrant locks, you could actually try to gain the lock for some amount of time. But if you're not able to gain the lock for some amount of time, then you would really want to relieve any of the locks which you have acquired till now. So I would just uncomment this part and then comment out the other locks which we have created. So I'm just trying to comment out any problems which we would have while working with this particular synchronized block. Okay, so now when we are actually trying to work with these reentrant locks, when we actually try for a particular lock, instead of blocking it directly, what we can actually do is we can actually use lock dot, and then we could try for a lock. Okay, and now you can see there are two ways we can do. We can either try for a lock directly without assuming that we might get into a deadlock situation, but then a better way is actually to try for a lock for some amount of time. So, let's say, for example, for 2 seconds, I would keep waiting for a particular, lock. And, here we would, I would say that, this is actually time in milliseconds, okay? Okay, so this is time unit in milliseconds. This is something which I would want to acquire. But, just in case I'm not able to acquire this particular lock, then I would, not try for this particular lock. And then, I would actually relinquish my efforts in trying to acquire any other lock. Or probably I would just, yield. If I do have any problem, in trying to acquire this particular lock, then I would just, simply yield, meaning that I would simply stop executing myself and yield for any other thread to actually, complete their execution before I go ahead. So what I would do is, once I try to, get that particular lock, I would just check, if I do get this particular lock, then, I would just go ahead. But, if I do not get this lock, so then what I want to do is I would actually, want to yield from the thread. If I'm not able to get this particular lock, forget it. I'm yielding myself. Go ahead, and other threads, please execute. Or I could, just do a wait also. Please, other threads, go ahead and, do some things while I'm waiting for any of you to notify me. So these are the various ways, in which I can actually work with locks and work with, this whole deadlock situation. So I'm just commenting this part out as well and uncommenting this part so that, it makes logical sense to you. And, these comments also help you in understanding how we actually, whatever we discussed in this particular lecture. So, all right, in this particular lecture, we saw how we could use reentrant locks. We have lock and lock 2. First, we acquire the particular lock, try to work on count. Then we try to acquire lock 2. And then we actually, relieve both lock 2 and lock. So the order should be like this. First lock 2 would get unlocked and then lock, and then in the other thread I'm actually trying to lock the lock 2 first and then lock, and then first relieve the lock and then lock 2. Now as you can see over here, I had to actually complete this particular code over here. Just because, I have something printed in the main, but I actually, could not complete the execution. That means, there was a particular deadlock which had happened. So now over here, if I just, comment out this part and we actually try to run this. Now we do have, okay, so it has gotten terminated over here. Let me actually try this again. Now it's not getting terminated. It just keeps running. It doesn't do anything. Okay, and the reason for that is because we have that particular whole lock and unlock situation happening in such a way that we have landed into a deadlock situation, and that is not something which we really want to do. So make sure that you are using the locks and unlocks properly. Make sure that you actually have something you're actually trying to lock for a couple of milliseconds and then relieving it if you do not get that particular lock for a long time, because now the user would not be just sitting and waiting for your program to get executed and just waiting infinitely in this particular deadlock situation. So this is the situation in which I was talking about. For example, you have these, trains coming in and you only have this particular passage, and you have these 3 trains now, wanting to take this passage. And if any of these trains, come and take this passage, for example, you have this particular train, which is actually, landing over here. The train wants to either go, on this track or on this track. But then, the tracks are already full of trains which are wanting to actually now use the track in which this particular train is in. So now we have a deadlock situation and there is no way to come out of this situation. Your program will hang forever. And similarly, the thread 1 is waiting for thread 2 and thread 2 is waiting for thread 1, and this is a deadlock situation. This is not something which we want to be in. So I would terminate my program over here. Make sure there is no deadlock in your program by, using the tactics which I just shared with you. In reality, we just, make sure that we work with locks judiciously, but it may be that our programs might get into a deadlock situation, and it's only when we land into a deadlock situation then we would want to actually use something like thread.yield. So don't stress a lot about that. And let's go ahead with the last topics in multi-threading now.